Well folks, welcome to the second Airspace tutorial video. In this video we're going to go over airspace configuration, depiction on sectional charts, as well as pilot equipment and weather requirements for different classes of airspace. For the first half of the video we'll use this Jeppesen chart to break out the different airspace configurations and review them and their depictions on a sectional chart. And for the second half we will just simply go over some of the requirements for pilot equipment and weather. Here we're going to look at Class G airspace at higher altitudes. We'll break out a part of this Jeppesen airspace chart here that depicts the higher altitude limits of Class Gulf airspace and talk about that. So over there on the left you see 14,500. We know that Class G in certain areas of the country goes up to 14,500. Over there on the right you see a notation about 1,500 AGL. So in that case, Class G, when terrain extends above 14,500, Class G there's a Class G buffer essentially above that terrain to 1,500 AGL. On the right side there you see that Mount Whitney extends to 14,491 feet MSL, and since 14,500 feet MSL is only 9 feet above that, Class G extends to 15,991 feet MSL above the summit of Mount Whitney. An interesting effect of this is that while our cloud and visibility requirements are 1200 AGL for Class G airspace, the buffer of controlled airspace or Class Echo airspace is 1500 AGL. So there's a 300-foot difference between cloud and visibility requirements for that 1 mile clear of clouds in Class G and the controlled airspace floor at 1500 AGL above terrain. What the basic effect of this is that you could be over the top of Mount Whitney at 1,000 feet and be 1 mile clear of clouds in Class G airspace. Once you climb up above 1200 AGL, you're still in Class G airspace, but now you are in Class G airspace above 10,000 MSL and above 1200 AGL, and so your cloud and visibility requirements jump all the way to 5 statute miles, 1,000 below, 1,000 above, and a mile away. It's an interesting result of the way that the airspace is set up. Over on the left side you see that the depiction of the sectional where we see Class G go up to 14,500 feet MSL, and it's depicted on the sectional like that. Outside the blue feathered line, Class G will go up to 14,500 MSL. Inside that blue feathered line it goes up to 1,200 AGL, and then we know that inside the magenta feathered line it goes up to 700 AGL. Alright, here we have another Class G area on the Jeppesen chart. This one talks about Class G airspace as it relates to the coast of the 48 contiguous United States, and shows us that within 12 nautical miles of the coast of the contiguous 48 contiguous United States, Class G, unless otherwise depicted, extends to 14,500 feet MSL. And here we can see an example of that where it's again showing the blue feathered line, and we're outside of that. It's kind of a double blue feathered line there, and that extends up to 14,500, or Class G extends up to 14,500 feet MSL in that area. There are areas where Class Echo the floor of Class Echo is lower, and therefore Class G will only extend up to either 1,200 or 700 along the coast of the United States, and you'll just have to look at your sectional chart to grab that depiction. As always, if we look at the sectional chart and it depicts Class Echo floor at 1,200 or 700 AGL, then we know that Class G airspace extends up to that floor but does not include it. So it would be like 699 or 1,199 for Class G in those situations. So just look at your sectional chart for these depictions. It should make sense what you're seeing. But generally speaking, the regulations say that within 12 nautical miles of the United States, 48 contiguous United States, Class G will extend to 14,500 feet. Alright, here we're going to talk about Class A and Class Echo above 14,500 feet. Class Echo extends up to but does not include the airspace at 18,000 MSL. Above that, Class A extends from 18,000, including 18,000 MSL, to flight level 600. Remember, the difference between flight levels and our altitude MSL is that in the flight levels, all altimeters on all aircraft are set to 299 or 2. So in the flight levels, we're using just an arbitrary 299 or 2 pressure datum plane. Class A airspace is not depicted on charts. The floor of Class E is depicted on charts, but the top of Class E is not. So on charts we don't see a depiction of the top of Class E at 18,000 MSL, and we don't see Class A airspace. Alright, now let's talk about Class E airspace as it applies to the visual airways that we're going to be flying some of our cross countries on. These are called Victor airways. They're typically 8 nautical miles wide, 4 nautical miles on either side of centerline, and they are Class Echo airspace from 1200 AGL up to 18,000 feet MSL. Sometimes the floor of Class E on the airspace drops down to 700 AGL, but this is associated with a specific airport and will be depicted on the chart. In fact, you can see there the airways are these 3 airways on our picture there of Sky Vector that go into a magenta feathered area. The short little piece of the airway that extends into that magenta feathered area is going to be Class E down to 700 AGL, but we can see that it is actually associated with the airport and not the airway itself. The depiction of the airways, the name will be a V and then a number. You can see on that Sky Vector picture there, Victor 17. That's how they're referred to. And they are Class Echo from 1200 AGL up to 18,000 feet MSL, with that one caveat that sometimes associated with certain airports, as depicted on the chart, it will drop down to 700 AGL. Now let's talk about Class E airports. Class E airports are airports that have Class E designated to the surface. This is denoted by a dashed magenta line. The floor of Class E in this area goes to the surface. Typically outside of that floor you'll have another feathered magenta area which designates the floor of Class E to 700 AGL. That's typical. The depiction you see there from our Sky Vector sample shows also the blue feathered area that is denoting Class E to 1200 AGL, and we also have an area where Class E only goes to 14,500 MSL. So we see all 4 possibilities there for Class Echo airspace. The Class Echo to the surface with the magenta dashed line over that airport, the Class Echo down to 700 AGL with the feathered magenta, and the Class Echo to 1200 AGL with the feathered blue, and then outside of that feathered blue area, Class E drops down to 14,500 feet MSL. Now let's look at Class D airspace. Class D, or Delta airspace, is depicted on the chart with a blue dashed line. Class D airspace typically surrounds small airports with operating control towers. Many times the operating control towers are not open for 24 hours. If it closes, the airspace on the field will revert to Class Echo or Class G, and we need to look at the AFD to find out what airspace the surface area reverts to. Class D, like I said, is depicted as a blue segmented line on the VFR chart. The altitude of the ceiling of Class D is depicted in a blue segmented square in MSL hundreds of feet. So 2500 MSL is depicted as 25 in a blue segmented square. Class D airspace typically extends to about 2,500 feet above primary airport elevation. This is typically, you will see examples where the amount is less. There was one we looked at in class, I believe, that the airport, or the Class D airspace went up to 2,100 AGL. Class C airspace is that airspace that surrounds busier airports, slightly busier than Class D. These airports justify a 24-hour control tower and are serviced by a 24-hour radar approach control. Class C typically has an inner 10 nautical mile diameter surface area and an outer 5 nautical mile band that has a floor somewhere above the surface. Total diameter depicted on the chart is typically 20 nautical miles. Altitude of each area is depicted with the ceiling above the line and the floor below the line. The inner Class C airspace in this case has a ceiling of 4,500 MSL and extends to the surface, and the outer 5 nautical mile band has a ceiling of 4,500 MSL and a floor of 2,100 MSL. Again, Class C typically extends about 4,000 feet above the surface of the primary airport. In this case, we can see area elevations about 500 feet above sea level, so this airport follows that typical progression of 4,000 feet above the airport. In addition, there is a 10 nautical mile band that is not depicted on the chart and is referred to as the outer area, where radar services are available to VFR and IFR aircraft. The only notation on the chart about this area is a white box that advises pilots to contact the appropriate approach control facility within 20 nautical miles. Alright, let's talk about Class B, or Bravo airspace. Class B is airspace typically associated with large airports with heavy airline and commercial traffic. Class B airspace typically extends from the surface to 10,000 feet MSL over the primary airport. Class B is large and is depicted with solid blue lines on charts. You can see on the SkyVector chart there how large that Class B airspace is. It has multiple shelves with multiple different floors, and all of the ceilings 10,000 feet MSL in this airspace area, but the floors are varied, and so you need to look at the chart depiction to find the floor of the Class Bravo airspace so you do not inadvertently enter it. As we know, we'll talk about this a little bit later in this tutorial, Class B requires a clearance to enter. So you do not want to inadvertently enter Class B. So it is extremely important that you're understanding how Class B is depicted on the chart and how to interpret its limits. Alright, this concludes the first half of this video where we just talk about airspace configuration and basic depiction on VFR charts. We're going to get more in depth into pilot equipment and weather requirements for the various airspace classes as we move on. Now let's look at basic pilot equipment and weather requirements for the airspace classes. We're going to go through these sequentially as opposed to the way that we looked at it in class. Those of you who learn a little bit better this way may appreciate this approach. I prefer the approach we talked about in class where we memorized just 4 exceptions to the basic 3152 rule. But for this video, it is beneficial to just go through it sequentially because we can use the FAA chart and hit some more specific points. Alright, let's talk about Class A airspace. Class A airspace is reserved for instrument flight rules operations and therefore has no minimum flight visibility or cloud clearance requirements. Class A required equipment is IFR equipment, since IFR operations are the only operations that are permitted. This is a much longer list than a transponder and a two-way radio. Class A pilot requirements, obviously you're required to have an instrument rating so that you can operate in Class A according to the regulations under IFR operations. For Class B or Class Bravo airspace cloud and visibility requirements, since all aircraft are under radar control, we can get away with a safe, clear of clouds minimum cloud clearance. Still, a minimum 3 statute mile flight visibility is required in Class B. Required equipment in Class B, since aircraft in Class B require a clearance to enter, a two-way radio is required. In addition, a transponder is also required in Class B airspace. Also, above and below Class B airspace, you must have a transponder. This is denoted on the chart by the Mode C veil, the small magenta or thin magenta line that surrounds all Class B airports in the United States. Class B pilot requirements. Students are allowed in the airspace of all Class B in the U.S. with a specific endorsement for that airspace. Student pilots may be allowed to land at the primary airport of a given Class B with a specific endorsement. Otherwise, the minimum certification to land at a primary Class B airport is private pilot. Now let's talk about Class C, or Charlie airspace. Class C cloud and visibility requirements. In Class C airspace, our standard 3152 visibility and cloud clearance requirements apply. 3152, as we've talked about in class, equals 3 statute miles visibility with 1,000 feet above, 500 feet below, and 2,000 foot horizontal clearance requirements. Class C required equipment. Since Class C airspace requires two-way radio communication, a two-way radio is required. In addition, operation in Class C as well as above Class C requires a Mode C altitude reporting transponder. As far as pilot requirements, student pilots are allowed to operate solo in Class C without a special airspace endorsement. Now let's talk about Class D airspace. Class D airspace cloud and visibility requirements are the standard 3152. Again, 3152 means 3 statute miles visibility with 1,000 feet above, 500 feet below, and 2,000 feet horizontal cloud clearance requirements. Class D required equipment is slightly less than that of Class C. Class D requires a two-way radio communication to be established, so a two-way radio is required, but no transponder is required for operation in Class D. For pilots, Class D permits student pilots to operate solo. No special airspace endorsement is required. Moving on now to Class E, or Echo airspace. Class E airspace, our 3152 standard visibility and cloud clearance requirements apply below 10,000 MSL. However, above 10,000 MSL, the cloud visibility requirement of 5 statute miles with 1,000 above and 1,000 below and a mile, 1 statute mile away or horizontal applies. So below 10,000 MSL, Class E uses the standard 3152. Above 10,000 MSL, Class E goes to the 5111 cloud and visibility requirements. For Class E, the required equipment below 10,000 feet, we don't need a radio. There's no two-way radio communication requirement or a transponder. However, a transponder is required above 10,000 feet MSL over the entire United States. Therefore, Class E above 10,000 MSL does require a transponder unless below 2,500 AGL at the same time. That 2,500 AGL caveat is in the regulations regarding transponder requirements. So basically, over the entire United States, transponders are required above 10,000 MSL unless you are also below 2,500 AGL. For pilot requirements, student pilots are allowed to operate solo in Class E without a special airspace endorsement. Alright, now let's talk about Class G airspace. Class G has quite a few differences depending on your altitude and the time of day. Class G airspace is a bit complicated, but it can be broken down. At night and below 10,000 MSL, Class G is 3152. Anytime we are in Class G and above 10,000 MSL and we are also above 1,200 AGL, then it's 5111. In between 1,200 AGL and 10,000 MSL, the standard 3152 applies. Finally, anytime we are at or below 1,200 AGL, 1 statute mile visibility and clear of clouds is the requirement. Class G below 10,000 MSL has no radio communication or transponder requirement. Class G above 10,000 MSL and above 2,500 requires a transponder because of the US-wide transponder requirement. Class G below 2,500 AGL, regardless of MSL altitude, does not require a transponder. Again, that is a part of the US transponder requirements denoted in the FARs. Class G pilot requirements. Student pilots are allowed to operate solo in Class G without a special airspace endorsement. I hope this video helps you out and helps you to understand the National Airspace System a little bit better. As always, I'm available via email. Get a hold of me that way is the best way to do it. And as always with these videos, if you find any errors or anything you're confused on, please let me know.